Hey there, everybody. So in this unit, we're going to start to talk about vectors. We're going to talk about what a vector is. We're going to talk about that terminology. We're going to talk about some of the terms involved, and then we're going to do some applications with it. Notice we're going to do these geometrically. Geometrically means we're going to do them mostly with pictures. So what we're talking about, a scalar, is the magnitude of a quantity, such as 45 pounds or a speed of 60 miles an hour. So why does we care about this? Because a vector in a plane is a directed line segment. It has magnitude. A vector has magnitude. Magnitude is what is the length of the vector. It's used to label whatever force we're talking about. And a vector will also have direction as indicated by our angles, our reference angles. So this vector, what this is showing me is that we have a force of 10 pounds on this vector. That's its magnitude. And it is 30 degrees above horizontal, and that's our direction. So every vector has two parts, magnitude and direction. And magnitude is often shown by length. The longer a vector, the more magnitude it has. So if we look at this vector, this is called vector OP because its initial point, it starts at O and it ends at P. That's called vector OP. Vector OP, as we are going to see in a moment, is not the same as vector PO. So magnitude is the length of this vector. It's expressed as the absolute value of OP. So we start at O and we end at P, and magnitude doesn't care about direction. It can be negative or it can be positive. So in this example, the magnitude of the vector is the distance between O and P. Okay. Now, two vectors are considered equal if and only if they have the same magnitude and the same direction. So vector OP and vector PO are opposite vectors. So they're not equal, they are opposite. They're the same length, but they go opposite directions. That makes them opposite. When we add them together, they have a resultant magnitude of 0. If you add two vectors together and that sum is 0, that means they are opposites. So to be equal, you have to go the same direction and have the same length, like A and B. Both A and B go up and left, and they are the same length. C and D are equal. They both go up and right. They're the same length. However, A does not equal E. They're the same length. But they don't go the same direction. So they're not equal vectors. And A and F are not the same vectors. They both go the same direction, but they are not the same length. So to be equal, they have to have the same magnitude and the same direction. So when we're talking equal, we are talking same magnitude, same length, same direction. So I want to just reiterate that. If you heard that, the dryer's done. So we are going to have the same length and the same direction to be equal vectors. Okay, if they go in opposite directions, the same length but opposite directions, they are opposite vectors. So let's name all the pairs of vectors that appear to be equal. So I'm looking at M here. M looks like if I took M and I put it right on P, they would be the same. So I'm going to say M and P are equal vectors. Is there anybody else that looks to be the same? M and T, nope. T is not the same length as M, so it is not an equal vector to M. O doesn't go the same direction as M, so they're not equal. However, N and R are equal vectors. They both go up and they're about the same length. R and S are not equal because S goes down and R goes up. Now, which of my vectors are opposites? I think M and Q are opposites, and that would mean P and Q are also opposite. N and S are opposites, and R and S are opposite vectors. I think I got them all. If you disagree, please let me know. So that's example number 1. What happens when we add vectors together? What does that look like? Well, when we add two vectors together, we're going to find what we call the resultant. There are 2 ways to find the sum of 2 vectors geometrically. The first way we can do is go the nose to tail. So to find the nose to tail, what we're going to do is we're going to have our first vector A. We have our first vector A right here. B starts off where A left off. We go nose to tail. So B starts off. Now the sum of those starts at where A started and it ends at B. So A plus B is the resultant, or the sum of A and B. Easy enough. So we just put the initial, we did vector A, B continues where A left off, and then when you connect the free points, you've got your sum. So let's do this. Let's sketch the sum of vector C plus vector G. Alrighty, so I'm going to give it a sketch here. So vector C looks like it does that. There's C. Now we're going to add G. G picks up where C left off. So G is going to come up and do this. I did my best to match G. So what is that sum? The sum starts where C started and it ends where G ended. So that is C plus G. Boom. Now, is it completely accurate? No, but is it a great visual representation? It sure is. And you know, I'm going to keep this one short. Let's go ahead and stop right here, and when we come back, we'll look at a different way to add vectors.